Hi, welcome to my Facts Hundreds. Have you ever stared into the mirror and felt something was slightly different about your eyes? Not dramatically different, but changed. Maybe older photos tell a different story. As a baby, your eyes were bright blue, yet today they're green, hazel, or even brown. This isn't an illusion, and it isn't rare. In fact, eye color is one of the most quietly evolving features of the human body. Most people grow up believing eye color is fixed at birth, like fingerprints. But science tells a very different story. Your eyes are alive with biological activity, constantly reacting to genetics, light, hormones, and time itself. From the moment you're born, your iris begins a slow transformation, sometimes subtle, sometimes dramatic. In this video series, we're uncovering the real science behind why eye color changes throughout life. No myths. No guesses. Just fascinating facts backed by biology. And it all begins at birth, when the human eye is anything but finished. The baby blues, why most newborns start with blue or gray eyes. When a baby is born, their eyes often appear blue or gray, regardless of what color they will have later in life. This happens because newborns have very low levels of melanin, the pigment responsible for color, in their irises. Melanin production hasn't fully started yet, so the eye reflects light in a way that makes it look blue, similar to how the sky appears blue. Take the case of a newborn named Elric Hayes, born in Oregon. At birth, his eyes were a pale steel blue. But that color wasn't permanent, it was more like a placeholder. In the early weeks of life, the cells responsible for producing melanin, called melanocytes, are still inactive or working at very low levels. This is why eye color at birth is not a reliable indicator of what a child's eyes will look like later. The color you see is more about light scattering than actual pigment. Melanin awakens, the real eye color begins to form. Around 6 weeks to 6 months after birth, something remarkable happens. Melanocytes begin producing melanin in response to light exposure. The more melanin produced, the darker the eyes become. This process can continue for up to 3 years, and sometimes even longer. For example, Rowan Calder, a toddler from the UK, had bright blue eyes at birth. By his first birthday, they shifted to green. By age 3, they settled into a light hazel shade. This gradual transition is completely normal and driven by genetic instructions interacting with the environment. Brown eyes develop when large amounts of melanin are deposited in the iris. Green and hazel eyes appear when melanin levels are moderate. Blue eyes occur when melanin remains low, allowing light to scatter within the iris instead of being absorbed. Why light matters more than you think. Light exposure plays a critical role in early eye color development. Once a baby is born, their eyes are suddenly exposed to light for the first time. This exposure stimulates melanocytes to activate and increase pigment production. Babies born in darker environments or during seasons with less sunlight may experience slower melanin activation. Meanwhile, increased light exposure can accelerate pigment development. However, light doesn't decide eye color on its own, it only influences how quickly genetic instructions are carried out. This is why two siblings with similar genetics may experience eye color changes at different speeds, even if they grow up in the same household. Genetics sets the range, not the exact shade. A common misconception is that eye color is determined by a single gene. In reality, eye color is controlled by multiple genes interacting together. These genes don't lock in one exact color, they set a range of possible outcomes. For instance, a child like Marlo Quinn may be genetically predisposed to green or hazel eyes. At birth, her eyes appear blue. Over time, they darken slightly but never reach brown, because her genetic range doesn't allow it. This genetic flexibility explains why eye color changes are most noticeable in infancy. The body is essentially deciding where within that genetic range the final color will land. Why some baby eyes never change. Not all babies experience noticeable eye color shifts. If a baby is genetically programmed to have high melanin production, their eyes may appear brown very early, and stay that way for life. This is why babies of African, Asian, or Latin descent often have darker eyes at birth. Their melanocytes activate quickly and produce pigment almost immediately. In these cases, the eye color change happens so early that it's barely noticeable. But even then, subtle deepening of color can continue silently over the next few years. When childhood ends, the eyes don't stay the same. As childhood fades and adolescence begins, the human body enters one of its most intense periods of change. Bones grow, voices deepen, emotions fluctuate, and surprisingly, the eyes can change too. Puberty introduces powerful hormonal shifts that can subtly influence eye color, even years after infancy. Many people assume that eye color is finalized by early childhood. In reality, puberty can reactivate melanocytes in the iris, leading to noticeable pigment redistribution. These changes are usually gradual, which is why many people don't realize they're happening until they compare old photos. Hormones and melanocytes, a quiet interaction. During puberty, hormones such as estrogen and testosterone surge through the body. These hormones don't just affect growth and mood, they also influence melanin production. Melanocytes respond to hormonal signals, sometimes increasing or redistributing pigment within the iris. Consider Lennox Pierce, a teenager from California. As a child, his eyes were light blue. By age 14, they had shifted to a muted green. The change wasn't sudden, but it was real. His iris wasn't creating a new color, it was altering pigment concentration within the genetic limits he already had. This is why eye color changes during puberty tend to stay within a similar color family rather than shifting dramatically from blue to dark brown. Common teen eye color shifts explained. The most frequently reported eye color changes during adolescence include blue turning into green, green becoming hazel, and hazel deepening toward brown. These changes occur as melanin density increases slightly in the iris, changing how light is absorbed and scattered. For example, Isla Fenwick, growing up in northern England, noticed her green eyes developing brown flecks during her teenage years. By adulthood, her eye color was classified as hazel. This wasn't random, it was a result of gradual pigment layering influenced by both genetics and hormones. True changes from brown to blue, however, are extremely rare and often signal medical conditions rather than natural development. Why some teens experience no change at all. Not everyone notices eye color shifts during puberty. If melanocyte activity stabilizes early, the iris may remain unchanged despite hormonal fluctuations. Genetics play the dominant role here, setting strict boundaries on how much pigment change is possible. Someone like Orion Blake, whose eyes were dark brown from early childhood, is unlikely to see visible changes during adolescence. His melanocytes already reached their maximum pigment output, leaving little room for further transformation. In such cases, the eye color remains steady, not because change is impossible, but because it's already complete. Light, lifestyle, and time working together. During teenage years, increased outdoor exposure, screen time, and lifestyle changes may slightly affect how eye color is perceived. Bright sunlight can enhance pigment visibility, making eyes appear lighter or more reflective at certain angles. This doesn't mean the eye color itself is changing daily, but perception shifts based on lighting and pupil size can make the color appear different. Over time, these small influences can blend with biological changes, creating the illusion of a more dramatic transformation. The emotional impact of changing eyes. For many adolescents, eye color changes can become part of identity. Teens may notice people commenting on their eyes looking different or brighter, reinforcing the idea that something has changed, even if they can't pinpoint exactly when. While subtle, these changes remind us that the body continues evolving long after birth. Eye color, often considered permanent, is still responding to growth, chemistry, and time. Eye color isn't frozen in adulthood. By adulthood, most people assume their eye color story is finished. But science suggests otherwise. While dramatic changes are rare after the teenage years, subtle shifts can still occur well into adulthood. These changes happen slowly, often over decades, making them easy to overlook. Adult eye color changes are less about growth and more about accumulation. Over time, environmental exposure, aging cells, and internal chemistry can influence how pigment behaves inside the iris. The long-term impact of sunlight. One of the most underestimated influences on adult eye color is sunlight. Just like skin, eyes respond to ultraviolet light. Long-term sun exposure can gradually increase melanin production in the iris, especially in people with light-colored eyes. Take Callum Rourke, a sailing instructor from Australia. In his early 20s, his eyes were a clear green. By his late 40s, they appeared darker, with a brownish undertone. This wasn't a sudden change, it was the result of decades spent under intense sunlight without consistent eye protection. This kind of shift doesn't create a new eye color but deepens the existing one, making it richer or darker over time. Aging and cellular wear inside the iris. As the body ages, cells lose efficiency, including melanocytes. In some individuals, melanin distribution becomes uneven, causing patchy or lighter areas in the iris. This can make eyes appear lighter, duller, or slightly different in tone. For example, Beatrix Holloway, now in her 70s, noticed that her once dark hazel eyes looked lighter and more golden than before. Aging caused subtle structural changes in her iris, altering how light reflects off it. These changes are gradual and natural, and they don't indicate damage or disease in most cases. Medications that can alter eye appearance. Certain medications can cause noticeable changes in eye color, especially treatments related to eye pressure or inflammation. Some glaucoma medications, for instance, stimulate melanin production and can permanently darken eye color. Julian Cross, diagnosed with glaucoma in his 50s, began using prescribed eye drops. Over several years, his light brown eyes became noticeably darker. This effect is well documented and occurs because the medication activates melanocytes in the iris. Unlike natural aging changes, medication-induced color shifts can happen more rapidly and may be irreversible. Health conditions and warning signs. While most eye color changes are harmless, sudden or uneven changes in one eye should never be ignored. Conditions such as pigment dispersion syndrome, Fuchs' heterochromic iridocyclitis, or certain eye injuries can cause unexpected color shifts. If someone like Nolan Ashford notices one eye becoming darker than the other in a short time span, it may signal an underlying medical issue rather than a natural transformation. In adulthood, the speed of change matters more than the change itself. Perception versus reality in adult eyes. Adult eyes can also appear to change color due to fatigue, lighting, clothing colors, or emotional states that alter pupil size. Larger pupils expose darker portions of the iris, making eyes look deeper in color. This optical illusion often leads people to believe their eye color is changing more than it actually is. In truth, the structure remains the same, the way light interacts with it has shifted. Inside the iris, more than just color. The iris is not simply a colored ring around the pupil. It is a complex, layered structure made of muscle fibers, connective tissue, and pigment cells. Its primary job is to control how much light enters the eye, but its structure also determines how eye color appears. Within the iris, melanin is stored in varying amounts and distributions. The more melanin present, the darker the eye appears. But it's not just the quantity, it's also how and where that pigment is arranged. How melanin creates every eye color. Brown eyes contain large amounts of melanin, which absorbs most incoming light. Blue eyes, on the other hand, have very little melanin. Instead of absorbing light, the iris scatters it, creating a blue appearance through a process similar to light scattering in the atmosphere. Green and hazel eyes fall in between. They contain moderate levels of melanin, allowing some light absorption and some scattering. This balance creates complex shades that can shift depending on lighting and surroundings. A person like Elliot Vaughn may notice their hazel eyes look greener outdoors and browner indoors. The pigment hasn't changed, the interaction with light has. True color change versus optical illusion. Not all perceived eye color changes are real. Many are optical illusions caused by light direction, pupil dilation, or reflections from clothing and surroundings. When pupils dilate, darker parts of the iris become more visible, deepening the eye's appearance. For instance, Maeve Callington noticed her eyes appeared darker during emotional moments or low-light settings. This happens because the pupil expands, altering how much of the iris is visible. True biological changes involve actual pigment redistribution or production, not just changes in lighting or emotion. The genetic blueprint behind your eyes. Eye color is controlled by multiple genes, not just one. These genes determine how much melanin your iris can produce and how sensitive melanocytes are to environmental triggers. Someone like Theo Ashcroft may carry genes that allow for gradual pigment increase over time. This means his eyes might darken slowly across decades without ever crossing into a completely new color category. This genetic framework explains why eye color changes stay within predictable limits and why extreme shifts are rare without medical intervention. Why eye color categories are simplifications. Terms like blue, green, hazel, and brown are human-made labels. In reality, eye color exists on a spectrum with countless variations. Tiny differences in pigment density can create entirely new shades that don't fit neatly into categories. That's why two people labeled as having green eyes may look completely different. The eye is responding to light, structure, and pigment simultaneously. This complexity is what makes eye color so dynamic, and why subtle changes can feel significant over time. Why science still finds eyes fascinating. Despite decades of research, scientists are still uncovering how genetics, environment, and aging interact inside the iris. Eye color is one of the few visible traits that can evolve naturally over a lifetime without signaling harm. It's a reminder that the human body is not static. Even features we consider permanent are quietly adapting beneath the surface. Myth: eye color never changes after childhood. One of the most common beliefs is that once childhood ends, eye color becomes permanent. In reality, while major changes are rare, subtle shifts can occur at any stage of life. These changes are usually slow and influenced by genetics, hormones, aging, light exposure, or health conditions. For many people like Sebastian Rowe, eye color doesn't suddenly change, but it evolves. What looks like permanence is often just gradual change happening too slowly to notice day by day. Myth: diet or emotions can change eye color. You may have heard claims that certain foods, emotions, or meditation techniques can change eye color. There is no scientific evidence supporting this. While emotions can cause pupil dilation, which temporarily alters how color appears, they do not change melanin levels in the iris. A person like Arden Knox might notice their eyes appear darker when angry or brighter when calm. This is purely a visual effect caused by pupil size and lighting, not a biological transformation. Myth: eye color can change instantly. Instant eye color changes are almost always illusions. Lighting, camera filters, reflections, and even clothing colors can influence how eyes appear. Real biological changes take months or years, not minutes or days. If someone experiences rapid or uneven color changes, especially in one eye only, it should be treated as a medical concern rather than a natural phenomenon. Reality: temporary versus permanent changes. Temporary changes include pupil dilation, lighting effects, and emotional responses. Permanent changes involve actual pigment alteration due to genetics, medication, aging, or health conditions. Understanding this difference helps separate fascinating science from misleading myths that circulate online. Reality, the future of eye color science. Researchers are exploring gene-based therapies and cosmetic technologies that may one day allow controlled eye color modification. While still experimental, this research raises ethical and medical questions about altering natural traits. For now, natural eye color changes remain a reflection of biology, not choice. Why eye color is a living story. Your eyes tell a story that unfolds over time. From infancy to old age, they quietly adapt to light, hormones, and life itself. Eye color isn't just a trait, it's a biological journey shaped by nature and time. Every subtle shift is a reminder that the human body is more dynamic than we often realize. So the next time you notice your eyes looking slightly different, remember, it's not your imagination. It's science at work. If you found these facts fascinating, imagine how many more secrets the human body is still hiding. If this topic connected with you, let us know in the comments. Have your eyes changed over time, or have you noticed it in someone close to you? We'd love to hear your experience. Don't forget to like this video, subscribe to the channel for more mind-blowing facts, and share this with someone who's always been curious about their changing eye color.